Hello and welcome to our tutorial, how to find the one sample C test. So in this tutorial, we're going to learn how to do the one sample C test, and we're going to do it with the calculator. When can I use the C test? Well, you have two conditions. You have to have a normally distributed population, which is going to look something like this, and you also need to have the standard deviation of the population. This is very, very important, and that will be given in the question when you have the problem. And you will hear the word normally distributed population. So the difference between a C test and a T test, which the T test we're going to talk about it in another video, is that you need to have sigma. This is called sigma, the standard deviation of the population, to use the C test. Now, let's do an example. So a candy store advertises that its best-selling candy only contains less than 23 grams of sugar. Well, 23 grams of sugar is a lot, but imagine if you have a candy that is very, very good and you see it and you're like, oh, I thought it was going to be like much worse than 23 grams of sugar. But you are a nutritionist and you look at this and you said, you know what? I have a feeling that these people are lying. I have a feeling that this candy is so sweet that maybe has more than 23 grams of sugar. So this nutritionist decides to take a test. So he runs tests of 40, and you will always see this, randomly selected candies. And he found that the mean, this is going to be what we call the X bar, was 23.56 grams of sugar per candy. Recent data show that the population standard deviation of the candy was only 1.34 grams of sugar. We're going to test this claim using the significant value of 0.05. You will see that all of this is very important to put into the calculator. So the calculator can give you the answer, but you need to understand what to put into the calculator. It will take literally 1 second. So I have my N, which is the number of trials, to be 40. I have my sigma, which is 0.05. I have my X bar, which is 23.56, and I have my sigma, or my standard, or the standard deviation of the population, as 1.34. So in this case, we need to set up the null and the alternative. Remember, the claim is always the alternative, because in this case they're saying that it's less than 23 grams of sugar. So your alternative is going to be mu, which is the mean of the population in general, is less than 23. Now, in this case, because your alternative, remember, the alternative can never, never, never have an equal. Never, never, never. But your whole, which is the null, is actually H sub 0, but I call it the whole. The whole is basically the one that says, look, I feel that mu is going to be equals to 23 because it's contradicting the alternative. That is why if I have mu less than 23 as my H, as the alternative, then the whole or the null has to be equals to 23. And this is what we consider a left tail, because left is because it's less than. So from there, I already know that I have a left tail. My N is equals to 40. My X bar is equals to 23.56, and my standard deviation is 1.34. That's all what I need to go to the calculator. Let's do it. Okay, so we have the calculator. So I want you to go to stats, and then from there, I want you to go to test. You can see here that you have C test, T test, two sample C test, and so on. This calculator is incredible for any class, anyone taking AP Stats, QMB, or basically just statistics. You're going to click on C test, and then look, you're going to put your if you put data, or if it's under data by mistakes, just put it under stats, because the stats are given. That means mu is 23. This is where you have your claim. Standard deviation of the population is 134. X bar is 23.56. N is equals to 40. And look at this area right here. In this area, you can tell the calculator, hey, I want a double tail, I want a left tail, or I want a right tail. In this case, because we're saying less than 23, we're going to choose a left tail, and we're going to do calculate, and bingo. We get that Z is 2.6431, and we get that P is 0.9959. So let's get this data, and let's go back to our problem to see what can we infer from here. Remember, if your P value is less than the significant value, then we reject the no or the whole. If your p-value is greater than the significant value, then we do not reject the whole. Or sometimes you can see in the problem they say we fail to reject the null. Okay, so in my case, I see that my p-value is 0.996, and we see this because we got it from the calculator. Now remember, the significant value is 0.05. This is what we call at the beginning of the problem to test the claim using alpha 0.05. Because 0.9960 is not less than 0.05, remember, if it's less, I reject. If it's not less, I do not reject. I do not reject the no. Basically, what does that mean? I do not reject the no. There is insufficient evidence to support the claim that the candy has less than 23 grams of sugar. The nutritionist was right. He looked at the candy, he said, ugh, this is way too sweet. I bet you there is more than 23 grams of sugar. So when he did the test, he can actually just confirm that there is insufficient evidence to support the claim that the candy has less than 23 grams of sugar. It can be either 23 or more than 23 grams. So I hope with this simple exercise you understood the magic of the one sample C test. Thank you so much. And please subscribe and like, please, 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 so I can make money and I can still make more math videos. So you can also go to my math tutor and you can see we have tutorials, quizzes, worksheets, and math calculator tutorials. Thank you so much, and thank you so much for learning.